So there's an important lab idea that we need to talk about when studying gas laws, and that's what happens when we collect gases over water. So here's an experimental apparatus, and this represents you've got a beaker filled with water and a test tube or a graduated eudometer tube that is also filled with water. And you can get a reaction to happen or bubble a gas into this test tube, and the gas will rise to the top. And what happens is, as that gas collects, it pushes down the water and it isolates the gas collection. So this is a clever way to isolate your gas. And since there was no air in there before, we know there's no contamination. It's what you get up here is just your gas, but not quite. Because we know that just an ordinary bottle of water, we know that water vapor can get into the air. So anytime we have water, some of these water particles are evaporating, and I don't just have air in there, I have some extra water vapor particles from the surface of this water that escape into the gas phase. So even though I had no air in here to begin with, in here I really have a mixture. So the total pressure inside this container is not just the pressure of the gas. It's the pressure of the gas plus the pressure of the water vapor. To find the pressure of the water vapor, we have to know the temperature of the water, because the temperature of the water depends, or the gas pressure depends on the temperature, because if you have, obviously if you heat up the water, you're going to get more water vapor to come off until you eventually get to the boiling point, and then it all starts to boil away. So this is generally a value you look up. This is a known referenced thing you look up in a lab manual or in a book, but this is what it looks like when you hear the phrase gas collection over water, or you hear this apparatus in the problem. In order to get the pressure of the gas, you have to know that this is a mixture, and part of the total pressure in this container, which we'll talk about in a moment, is equal to the gas pressure plus the water vapor. Separately from that, we also know when we're collecting this, there is a way to measure the pressure in this container, and it is generally going to be equal to the pressure of the air in the room, because the air outside the room is going to be equal to the air or the push inside of there under certain conditions. So there's a way to measure that, but this is a way, if you know the air pressure in the room outside of the container, then that's going to be the same as the pressure inside of the container when that measurement is taken. So that gives us a way to take this one. We subtract away the water vapor depending on what the temperature is, and then we're left with the pressure of the gas. And this is really what we're after, because we have the pressure of the gas. This particular experimental apparatus can also show us the volume of the gas, because we can measure the volume. So all of a sudden we've got pressure and we've got volume, and we can start doing some gas law calculations depending on what we needed for that gas in the mixture.